Welcome back. This is video number 3 for domain and range, still under the topic functions. The next example, we'll have a function, algebraic function still involving radicals. Let's have y equals the square root of, let's take x minus 4 as the radicand. Let's find its domain and range. If a function involves a radical, you always have to look at the index of the radicand. The index, you'll find it here. So if there is no number written there as the index, we understand that the index is 2. So this is a square root symbol. Okay, square root symbol. If the index of the radical is an odd number, then we don't have to worry about the domain of the function. The domain will be the set of real numbers. That is, if the index is an odd number. Now I have written that for you to remember. Okay, now if the index is an even number, then you will always have to solve for the domain using inequalities. Why is that? Why is that so? When the index of the radical is an odd number, then you can always have this radicand be any number, be equal to negative, a positive number, or a 0. But when the index is an even number, remember that this radicand cannot be a negative number. Okay, so the smallest possible value for this expression, which is x minus 4, is 0. It can be any positive number, but not a negative number. So in the function y equals square root of x minus 4, the smallest possible value for x minus 4 is 0. It should be 0. It must be 0. So x minus 4 must be greater than 0, or it can be equal to 0. So this inequality will give you the correct answer for the domain. Okay, so just transposing negative 4 to the right side of the inequality, you'll have x greater than or equal to 4. To 4. Now what does this mean? This means we want all the numbers, x are all the numbers equal to 4, or greater than 4. It can be 4.001, 4.01, 4.99, 5, 6, 7, and so on and so forth. In interval notation, this is 4 to positive infinity. So 4 is included in the set, okay, in the solution set of x greater than or equal to 4. So we start from 4 up to any positive number, because x can be any number greater than 4, right? So that would be the domain of the function y equals square root of x minus 4. So 4, from 4 to positive infinity. Now for the range of the function, remember the smallest possible value for x is 4, right? So when x is equal to 4, what happens to x minus 4? X minus 4 becomes 4 minus 4. Okay, let me just rewrite that. When x is equal to 4, then x minus 4 becomes 4 minus 4. 4 minus 4, that's equal to 0. So then square root of x minus 4 becomes square root of 4 minus 4. That is square root of 0, which is equal to 0. So when x is equal to 4, y is equal to 0. Okay, because this is y. Okay, y is equal to square root of x minus 4. Okay, so the lowest possible value for x is 0. For x is 4. Therefore, the lowest possible value for y is 0. Okay, because this is square root, y is always a positive number. Okay, y is always a positive number, but then it can also be equal to 0. Therefore, the range is from 0, okay, to positive infinity, because y can be equal to 0. Y is equal to 0 whenever x is equal to 4, okay, and it can be any positive number, right, because this is a square root. Right? So the range is from 0 to positive infinity. I hope in this example you realize why y cannot be a negative number, because the square root of, well, the square root of, first of all, the square root of a negative number is a complex number, right? We know that the square root of negative 1 is denoted by I, which is a complex number. And then y must be a positive number because the index is an even number, because the square root or the fourth root or the sixth root of any positive number is also positive. We will just be dealing with the principal roots here, okay? Not with the secondary or the others. So whenever the index of the radical is an even number, y should always be a positive number or a 0. Okay? We move on to the next example. The next example is still a function involving a radical, again a square root. Okay, we have to find the domain and range of the function. To find the domain, we don't have to look at -1 here anymore, because we'll just need the numbers that we can substitute for x, remember, so that the function remains defined, or the function does still make sense. Again, whenever the function involves a radical and the index of the radical is an even number, we just have to make use of inequalities. So we take this radicand, x plus 5, and then it must be greater than or equal to 0 again, because the radicand cannot be a negative number. So it can be a 0 and it can be a positive number, but it can't be a negative number. Hence, the inequality symbol greater than or equal to. Solving for x, transposing 5 to the right side, we'll get x greater than or equal to -5. Okay, so this means that we are referring to x. So we are referring to all the numbers x equal to -5 or greater than -5. Okay, so in interval notation, that would be we start from -5 to positive infinity. If you have the symbol greater than or equal to, we'll always be making use of brackets in the interval notation. So the smallest value for x is -5. The highest value, we don't know that. So it can be any positive number, very, very large positive number. So we just make use of the symbol positive infinity. So that would be the domain of the function. The domain from -5 to positive infinity. Now for the range of the function, for this we have to consider the -1 in the function. Okay, the -1 over here in the function. Okay, so since we have a square root symbol involved in the function, and then the lowest value that we can substitute for x is -5, then whenever x is -5, we have y equals square root of negative 5 plus 5. That would be equal to 0, right? But we have minus 1. So we have y is equal to square root of 0 minus 1, and that is 0 minus 1, y is equal to negative 1. So therefore, the lowest value for y is negative 1. The question is, what is the highest value for y? Since we know that square root of x plus 5 must always be a positive number, 0 or a positive number, but then we have in the expression, in the function, we have square root of x plus 5 minus 1. So the lowest value for y is not just 0, but we have this number over here, negative 1. Okay, so this again, the lowest value for y is negative 1, and the highest value is, we don't know that. It can be any positive number, right? So to denote that, so we start from negative 1. Again, y can be equal to negative 1. We can see that. And that happens whenever x is equal to negative 5. And then y can be any positive number. So that's the interval notation bracket, negative 1, positive infinity, close parenthesis. So that's the correct answer. Okay. Let me just give you or sketch the graphs of some very common transcendental functions so that you easily identify their domain and range. Their graphs do not change, okay, and their domain and range do not change also. In number 6, we have the function y equals ln of x. Well, I hope you know that ln of x is actually logarithm of x to the base e. Okay, that number e. So if you have a logarithm to the base e, we simply call it ln of x, or that is ln of x. The graph of the ln function is asymptotic to the x-axis. Okay, when we say asymptotic, so it will the graph will come closer and closer to the x-axis, but no, I mean y-axis. The graph is asymptotic to the y-axis, I'm sorry. It will come closer and closer to the y-axis, but it will never touch the y-axis. So it passes through the point 0, 1, or 1, 0, 1, 0, okay? And then asymptotic to the y-axis, so it's like this. So it's not a line, it's a curve. Goes all the way to the right and upward. Okay, so based on the graph, the domain of the function, so it will not touch the y-axis. So this is the y-axis. The equation of the y-axis is x equals 0. Therefore, this is x equals 0. So it will not touch the number 0 on the x-axis, but it will come closer and closer to the y-axis. Okay, and then it goes all the way to the right, So the domain of the function, it goes all the way to the right. We don't know how far it goes, so it can be any, the points here covers all the positive numbers on the x-axis. Actually, it's the x-axis, but it does not cover, the graph does not cover the negative numbers on the x-axis, because as you can see here, there is no graph on the left side of the y-axis. Okay, so the lowest value for the domain of the function would be, we don't know, it's any number very close to 0. So 0 is not included in the domain because the graph doesn't touch the x-axis, or the y-axis, I'm sorry. So it's in between 0 and positive infinity. Okay, positive infinity because the graph goes all the way to the right, but not all the way to the left. We have a limit here. It does not touch 0 on the x-axis. It just comes closer and closer to the y-axis, but will never touch the y-axis. Okay, so 0 is not included. to indicate that 0 is not included in the domain, we use parentheses instead of bracket. Okay, now for the range, as you can see, the graph goes all the way up here. As it goes to the right, it goes up. And then it goes all the way down. As it comes closer and closer to the y-axis, goes all the way down. Okay, so again, from based on the graph, the function will cover all the numbers on the y-axis as it goes up and down. Okay, so the range would be from negative infinity to positive infinity. It passes through the point 1, 0 because when x is 1, y is equal to ln of 1, and ln of 1 is equal to 0 according to our calculators. Now, on the other hand, we have the function y equals e to the x. That's an exponential function, which is actually the inverse of the natural. This is the natural logarithmic function in number 6. Okay? So, if the ln function is asymptotic to the y-axis, the natural exponential function is asymptotic to the x-axis. So it means to say that it doesn't touch the x-axis. It just comes closer and closer to it. Okay, now this passes through the point 0, 1. This is the point 0, 1. It goes all the way up also to the right, and then goes to the left all the way. So it's like this. And then asymptotic to the x-axis there. Okay. Now looking at the graph, let's find the domain of the function. Now this part of the graph goes all the way to the right. This part of the graph goes all the way to the left. So it means to say that the graph will cover all the numbers on the x-axis as it goes to the right and to the left. Okay? So the domain is the set of real numbers from negative infinity to positive infinity, or you can just make use of the capital letter R to denote the set of real numbers. Okay? Now what about the range? Now this part of the graph goes all the way up as it goes to the right. So it goes all the way up. But this part of the graph doesn't go beyond the x-axis. And the x-axis has the equation y equals 0, because this is y equals 0, right? 0. Okay, so it doesn't touch the 0, the number 0, on the y-axis. And as you can see, there is no graph in this part. Okay, in this part of the plane. So therefore, the lowest possible value for y is a number somewhere very, very close to 0, but not equal to 0 because the graph will not touch that number. Okay, so therefore the range of the function, we use parentheses to denote that 0 is not included in the range, to positive infinity because the graph goes all the way up. It doesn't stop. Okay. For the trigonometric function sine, the graph is like a wave and it passes through the origin. Okay, passes through the origin. Now the highest point happens at y equals 1. The lowest point happens at y equals negative 1. 1, negative 1. So it's just like a wave going back and forth like that. On the other side also like that, and so on. Okay, now it goes on the left and right side. Okay, so by looking at the graph, the domain of the function is the set of real numbers because this goes on and on to the left, and on the other side goes on and on to the right, making the same wave over and over again. Okay, so the domain is the set of real numbers. And in the graph, I have already mentioned that the highest point happens at y equals positive 1. The lowest point happens at y equals negative 1. The graph doesn't go beyond these numbers on the y-axis. So the lowest number on the y-axis that the graph covers is negative 1. The highest number that the graph covers on the y-axis is positive 1. Therefore, the range is from negative 1 to positive 1. We use brackets because both negative 1 and positive 1 are included in the range because of the highest points and the lowest points. Okay, this domain and range do not change. Now, for the cosine function, the graph is very similar to the graph of the sine function, except that it does not pass through the origin. Okay. Why does the graph of the sine function pass through the origin? Because in the sine function, when x is equal to 0, we have y equals sine 0, and sine 0, according to our calculators, is equal to 0. So whenever x is 0, y is 0, therefore it passes through 0, 0, or the origin. But then for the cosine function, whenever x is equal to 0, y is equal to cosine 0. Cosine 0 is not 0, but is equal to 1. Okay? But still, the highest and the lowest points of the graph happens at positive 1 and negative 1, respectively. And then, as you can see, whenever x is 0, y is equal to 1, so it passes to the point 0, 1. And 0, 1 happens here. But it's the same wave as the sine function. So, still like this. Like that. And again, this goes all to the left and to the right all the way, making the same wave over and over again. So on the x-axis, we have covered all the numbers as the graph goes to the right and left. So the domain is the set of real numbers. While the range, again, as we can see, the highest point happens at y equals 1, and then the lowest points happen at y equals negative 1. It doesn't go beyond these numbers. So the range would be from negative 1 to positive 1. For interval notations, we always have to start from the smallest number. So on the left side is the smallest number, and on the right side of the interval notation is the highest number in the set. Okay? Now try to find a book or use the internet to solve some problems.